Hello and welcome back to Quadrilateral Theorems with Mathomat. Session 3 is all about exploring different ways in which to prove a quadrilateral to be a rectangle. In part 2, we will explore a second theorem for the proof. So let's investigate Theorem 2. How to prove that a quadrilateral is a rectangle. In Theorem 2, we've got two conditions that we need to meet. First of all, we need to prove the quadrilateral to be a parallelogram. And second of all, it should have one right angle. The first condition we can prove from what we have learned from session 1. I'll use Theorem 2 from that session, which states that both pairs of opposite sides must be congruent. Let's head on over to the Mathomat template. On your template, there is a scalene right-angled triangle, shape number 31. We'll use this for the proof. Are you ready? Let's Mathomat this. Before we start our proof, let's quickly have a look at the properties of the scalene right-angled triangle. This triangle has all three of its sides at different lengths. It also has a 90-degree angle. With your template, draw the triangle. You will draw a second triangle, but we will apply some transformations. We will rotate the second triangle so that the two hypotenuses forms a diagonal for the newly formed composite shape. And this shape, you will notice, is a quadrilateral. So we apply the properties of the triangles to the quadrilateral and we can prove it to be a rectangle. Both pairs of the opposite sides are congruent and you can use any of the two 90-degree angles to prove that this quadrilateral is a rectangle. If we use the inverse of this process, you can also prove a rectangle. If you halve any quadrilateral along one diagonal and the angle opposite that diagonal is a 90-degree angle, or if it fits onto the 90-degree angle of the scalene right-angled triangle, then that quadrilateral is a rectangle. This test will work on a square as well. You cannot, however, build a square using the scalene right-angled triangle. You will have to use the isosceles right-angled triangle, which is shape number 43. So this is where I leave you to go and explore this investigation. We have successfully proven this quadrilateral to be a rectangle. We used transformation along with properties of two scalene right-angled triangles. This is the end of part 2 of session 3 on quadrilateral theorems. Please join me, Michelle, in part 3 for the next theorem. See you then!